Hello students, welcome back to our class. In this module we are going to discuss about essay type questions which were given frequently in the chapter circles. Coming to the very first problem here, in figure PQ is chord of a circle of length 8 centimeters, of radius 5 centimeters, and the center is at O. The tangents P and at P and Q intersect at a point T because T is an external point. Find the length of TP. See the problem given here, I would like to draw the figure again. So this is a circle, this is a point outside the circle, this is tangent TP as well as this is tangent TQ, okay. This is point T and there is a center, let O be the center of the circle, and this is the radius, and this is a chord whose length is equal to 8 centimeters. Of a circle of radius 5 centimeters. The tangents are, these are the tangents. Find the length of TP. TP is equal to how much? Let it be some x. And if I would like to join this, okay, radius is given as 5 centimeters. So this is 5. This total one is equal to 8 centimeters. Okay. Let this point of intersection is equal to some m. Okay. Now I would like to have a few things here. Those few things are that TPQ is a triangle and where TMP is 90 degrees. TMP is equal to 90 degrees. So that was the result already proved. That's why you don't have to prove it again. It is already 90 degrees. And you know that this angle is equal to this angle. Okay. Let this be theta. Okay, this angle is also equal to theta. It is theta, it is 90, so that this only angle in this triangle is going to be 90 minus theta. Okay, and this entire angle is equal to 90 degrees because radius is perpendicular to the tangent through the point of contact. And this is theta, this entire thing is 90, so this angle is going to be 90 minus theta. So no more confusion, right? If you observe, this triangle PMT is congruent to QMT, and then by CPCT, this part is equal to this part. This total length of PQ is equal to 8 centimeters. So the length of PM is equal to 4 and MQ is equal to 4. Am I clear? So they are 4 and 4. And one more very important thing here it is, this is 90 degrees, right? If this is 90 degrees, then in triangle POM, triangle, first of all, I will just write everything here. PTM, triangle PTM is congruent to triangle. See, PTM is congruent to QTM, congruent to QTM. By which congruency criteria? Already you proved that this entire triangle is congruent to this entire triangle when I join this O and Q. Okay, by RHS congruence. Then by CPCT you can say that this angle is equal to this angle, this side equal to this side, and this is the common side for both the two triangles. That is by SAS congruence. By SAS congruence. So therefore you can say these two angles are equal. That is what triangle PTM, angle PTM is equal to angle QTM, which is equal to theta. Okay, and PM is equal to MQ, PM is equal to MQ is equal to half PQ, which is equal to, PQ is equal to 8, half PQ is equal to 4 centimeters, and angle PMT, which is equal to angle QMT, which is equal to 180 by 2, which is equal to 90 degrees. That is what is the information being provided. So now this is 90 degrees. So it is now 4 centimeters, it is also 4 centimeters. Now I am going to consider two triangles here. Those two triangles are, like this is 4 and this is 5. Can you find out this OM here? In triangle, what is the triangle? PMO. In triangle PMO, hypotenuse is, this is hypotenuse OP. So OP square equal to PM square plus MO square. OP square is equal to PM square plus MO square. OP is equal to 5. So 5 square is equal to PM square is going to be 4 square plus MO square. Therefore, we can say that MO is equal to 3 centimeters. MO equal to 3 centimeters. So this is 3 centimeters. I am writing directly there. Now I have two right angle triangles, and those two right angle triangles are similar. Which two right angle triangles they are? See, this is 3, and I do not know what is this TM. Let TM is equal to some Y. Okay. Those two right angle triangles are, here it is theta. It is 90, this is 90 minus theta, it means this is theta, this only angle is theta, correct? So this is theta, in which triangle? TPO triangle and MPO triangle. So those two triangles I will write them in order. In triangle, what is that? T, and the triangle, here T is equal to theta, here P is equal to theta. And here in this triangle, in this entire triangle, like what it is? It is 90 degrees. So that 90 is at P. So it is P. In this small triangle, 90 is located at M. So M. Theta 90 over, and 90 minus theta is this, that is O. And in this triangle, where is that 90 minus theta? Of course, 90 minus theta is O only. These two triangles are similar by AA similarity. Since two triangles are similar, by CPST, TP divided by PM is equal to PO divided by MO is equal to TO divided by PO. Hope you understand. Now substitute the values. TP, what is TP? I do not know. That is X divided by PM. PM is equal to 4, so X divided by 4 is equal to PO. PO is equal to 5 divided by MO. MO is equal to 3 is equal to, finally TO, that is Y plus 3 whole divided by PO is equal to 5. Okay. So now you see here, in order to find the value of X, I can equate only these two. Nothing more than that. So that is 3 into x is equal to 3x is equal to 5 4s are 20. Therefore, the value of x is equal to 20 divided by 3 centimeters. That is what is the length of the tangent in this particular case. So this is one of the easiest way to find out the value of x by using similarity criteria. You understand? This problem can be solved in other way, taking Pythagoras theorem 2 times for this triangle as well as this triangle. Then also we'll get the value of x as well as y. So, but this is what I feel is the most easiest way in order to find the value of x. Coming to the next problem, if the angle between two tangents drawn from an external point of a circle, this is a circle, this is a point outside the circle, this is the radius, this is one tangent, this is one more tangent, these two are points of contacts, let it be A, and this is B, this point is P, and the circle with center is equal to O. If the angle between two tangents drawn from external point P to a circle of radius small a is 60 degrees, so this entire angle is equal to 60 degrees. If this entire angle is equal to 60, when you join O and P, okay, then this 60 is divided into two equal parts, so one is 30 degrees and the other part is also 30 degrees, as we already proved it. So find the length of OP. This is what is the length of OP. This is A and this is 30 degrees and it is already it is already 90 degrees. This is what we want. Why don't we apply sine 30 degrees? If you apply sine 30 degrees, sine 30 degrees is equal to side opposite to 30 is small a divided by hypotenuse is equal to OP. Sine 30 is equal to 1 by 2 is equal to A divided by OP. Therefore, OP is equal to 2 times small a. That is what? 2 times radius is the length of OP. This is a very simple problem, but this problem was given for 5 marks. Right, next. In figure, a circle is inscribed in a triangle, that is what called incircle, such that BC is equal to 8, AB is equal to 10, AC is equal to 12. Find the length BL, CM and AM. So this is a quite interesting problem, if I am not wrong, that I am going to answer this problem just by using one property, that radius is perpendicular to the tangent through the point of contact, and the second one is lengths of tangents drawn from an external point of a circle are equal. So how many tangents are drawn and how many external points are there to the circle? See, for example, A is one external point to the circle. They are AN and AM are tangents. We know that AN is equal to AM. And B is one external point to the circle, BN is equal to BM. And C is an external point of a circle, that BL is equal to BM. Right? So we know external points, lengths of tangents drawn from external point of a circle are equal. Now, my point here is this total length is equal to 8 centimeters. I am taking BL is equal to some x centimeters. If BL is equal to x, this total one is equal to 8, then what is the length from L to C? Total one is 8, right? So it is going to be 8 minus x. Am I clear? If that is 8 minus x, and from C is an external point, so CL is equal to CM. They are also equal. Since it is 8 minus x, this one also 8 minus x. And this total length of CA is equal to 12 centimeters. Then MA is going to be 12 minus of 8 minus x. What is 12 minus of 8 minus x? 12 minus 8 equal to 4. Minus of minus is equal to plus x. So the length of AM is equal to 4 plus x. If AM is equal to 4 plus x, then AN is also equal to 4 plus x. Right? And see, BL is equal to BN, right? Because they are tangents from B. So if it is x, this is also x. Now you see clearly. This is 4 plus x and this is x, but this together constitute 10 centimeters. So finally, I would like to tell that 4 plus x is equal to 10 centimeters. Okay? So 4 plus 2x is equal to 10 centimeters. Then 2x is equal to how much? 4 plus how much equal to 10? 4 plus 6 equal to 10. 2x is equal to 6, then x is equal to 3. X is equal to 3 means what? BL is equal to 3 centimeters. Therefore, BL is equal to x, which is equal to 3 centimeters. And then we want CM. CM is equal to what? CM is nothing but, this is CM is 8 minus x. 8 minus x is equal to 8 minus 3, which is equal to 5 centimeters. And next one is AN. AN is equal to 4 plus x. AN is equal to 4 plus x. That is 4 plus 3 is equal to 7 centimeters. So this way we can answer this problem easily. You understand? Right. So coming to the next one. Prove that the parallelogram circumscribing a circle is a rhombus. This is one of the compulsory question all time. Prove that the parallelogram circumscribing a circle. What do you mean by circumscribing a circle? Outside the circle. See, this is a circle and I am going to draw one parallelogram. So this is one parallelogram outside the circle. Right. This is a parallelogram circumscribing a circle. So the points of contacts are, these are the points of contacts. Okay. So parallelogram is going to be, suppose A, B, C, D is a parallelogram. The points of contacts are, let it be P, Q, R and S. Okay. Now I would like to write the given information. So what is the information given in the problem? A, B, C, D is a parallelogram. A, B, C, D is a parallelogram. What do you mean by parallelogram? In parallelogram, opposite sides are equal. Opposite sides are equal means AB is equal to CD and AD is equal to BC. AB is equal to CD and AD is equal to BC. What are you going to prove now? You need to prove that parallelogram ABCD is a rhombus. So here you will have to understand the comparison between parallelogram to the rhombus. When a parallelogram is said to be a rhombus, see, you are not proving a quadrilateral is a rhombus. You are proving a parallelogram is a rhombus. That is not just a quadrilateral, that is a parallelogram. So when a parallelogram is said to be a rhombus, So coming to the properties of rhombus, a rhombus is a parallelogram in which one pair of adjacent sides are equal. It means in ABCD, we know AB is equal to CD and AD is equal to BC, but AD and CD are not equal. Suppose if AD and DC both are equal, can we call this as a rhombus? Because they are pair of adjacent sides are equal. We know this side is equal to this side, but these two sides are not equal. Suppose if these two sides are also equal, then all the four sides are equal. Then if all the four sides are equal in a parallelogram, that is said to be rhombus. So in order to prove a parallelogram is a rhombus, it is enough to prove that one pair of adjacent sides are equal in a parallelogram. Okay, so that is one pair of adjacent sides are equal. One pair of adjacent sides are equal in parallelogram. So how do you prove that one pair of adjacent sides are equal in a parallelogram? For that, I am going to do one thing here. Just I use the property that tangents drawn from external point of a circle are equal. Okay? So since tangents drawn from an external point, tangents are drawn from an external point of a circle are equal. So what are the tangents drawn from external point of a circle? Let us start from point A. Can we say AP is equal to AS? AP is equal to AS. Now from B, BP is equal to BQ, BP is equal to BQ, and from C, CQ is equal to CR, CQ is equal to CR, and from D, DS is equal to DR. DS is equal to DR. What am I supposed to do here? Consider sum of opposite sides. I am considering sum of opposite sides, that is AB plus CD. Okay? AB plus CD. How can I write this AB here? AB can be written as AP plus PB, AP plus PB, and CD can be written as CR plus RD, CR plus RD. Now you see clearly, instead of AP, I can write AS. Instead of PB, I can write BQ. Instead of CR, I can write CQ. Instead of RD or DR, I can write DS. So if I write this AS as well as DS together, and BQ and CQ together, AS plus DS. What is AS plus DS is equal to AD, that is AD, plus BQ plus CQ. BQ plus CQ is going to be BC. So finally what I proved, AB plus CD is equal to AD plus BC. That is what I proved. But since ABCD is being a parallelogram, I know AB is equal to CD. So instead of CD, can I write AB? So AB plus AB is equal to AD plus, instead of BC, can I write AD again? AD. So AB plus AB is equal to 2AB is equal to AD plus AD is 2AD. So 2 gets cancelled. Finally, AB is equal to AD. It means one pair of adjacent sides are equal. Since one pair of adjacent sides are equal, therefore ABCD is a rhombus. Right? So this is one of the interesting ways of proving ABCD is a rhombus. When a parallelogram is in circumscribing a circle, then it is a rhombus. So this is one of the easiest ways to prove this statement. Please be focused. So coming to the next problem. Here in a right angle triangle ABC. So let me draw one right angle triangle ABC. BC is equal to 12, AB is equal to 5. And find the radius of the circle inscribed in the triangle. Find the radius of the circle inscribed in triangle means this is one circle inscribed in a triangle. Okay. So What about right angle here? BC is equal to 12, AB is equal to 5. So BC is equal to 12, AB is equal to 5. So B is common here. If I take B here, then BC as well as, if I take B here, BC is equal to 12. If it is B, this is C and this is A. Okay. Now obviously angle B is equal to 90 degrees. Angle B is equal to 90 degrees. BC is equal to 12. This total one is equal to 12 centimeters. And BA is equal to 5. So this is 5 centimeters. Okay. If it is 12 and it is 5, what about AC? So according to the Pythagoras theorem, AC square is equal to AB square plus BC square. So AC square equal to AB square is 12 square plus BC square is equal to 5 square. 12 square equal to 144, 5 square equal to 25. 144 plus 25 is equal to 169, which is equal to 13 square is AC square. Therefore the value of AC is equal to 13. So I got the hypotenuse, that is 13 centimeters. So this is 13. So after finding hypotenuse, now this is what is the center, this is the radius, and this is also the radius, right? Radius is perpendicular to the tangent, here also perpendicular to the tangent. Once you observe, let this point is some P and it is Q and it is R. These three are points of contacts. Especially quadrilateral BPOR. Quadrilateral BPOR. In this quadrilateral, three angles are equal, which are equal to 90. And see, this is R and this is R. These two adjacent sides are equal and these two adjacent sides also equal. BR is equal to BP. In a quadrilateral, three angles are 90 degrees, means obviously third angle is also 90 degrees. Means it should be a rectangle. But in rectangle, adjacent sides are not equal. But here adjacent sides are equal. If in a rectangle, adjacent sides are also equal, then it should be a square. Right? So clearly, OPBR is a square. Clearly, OPBR is a square. So since it is a square, then all the four sides are equal. This is R, this is also R, this is also R. Again, coming to the same point, this total length is equal to 5. This is R, then PA is going to be 5 minus R. And AP is equal to AQ because tangents drawn from external point of a circle. So this is 5 minus R, this one also 5 minus R. And what about CQ here? CQ is equal to 13 minus of 5 minus R, which is equal to 13 minus 5 plus R. 13 minus 5 is equal to 8 plus R. So this is 8 plus R. If this is 8 plus R, this one also 8 plus R. But finally, CB is going to be CR plus RB. CR plus RB. So CR is equal to 8 plus R plus RB is equal to R, which is going to be totally 12. So R plus R is equal to 2R. 12 minus 8 is equal to 4. Then R is equal to 2 centimeters. Therefore, radius of a circle is going to be 2 centimeters. So these are about long essay type questions, and sometimes you will be given for long answer type questions also. You can expect anything. So these are the most important problems which were given in the previous board examinations. So please be focused, and the way and the strategy that I apply to answer the problems, you please do follow, and definitely you can score very, very, very good marks in your coming board examination. Hope you understand, enjoy the class. Thank you.